Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel Chemistry, the Mystery of Molecules. Today's topic of discussion is one MCQ. So you can see the MCQ. I request you student, please pause the video, try by yourself, and whatever answer you get, please write in the comment box along with some explanation. Don't hesitate whether your answer will be right or wrong, because self-evaluation is essential for improvement. And don't worry, after some time we will get the complete explanation and the right answer. Now let's start. So if you look at this problem little closely, first this is a molecule and it reacted with LDA, dry THF, and second TMSCl, third is 60 degrees centigrade heat. So it's a multiple step reaction. So in this case it is better to understand the nature of the reagent and what are the nature of the reactant and reagent given. See, LDA is actually a bulky base. Okay, so it selectively abstracts proton from less bulky site. Now in this case there are two types of proton I guess available. One is this allylic and this is alpha 2 carbonyl, and we know alpha 2 carbonyl protons are relatively more acidic. That's why this LDA means N-diisopropyl amide, which is bulky base, will abstract this proton and produce this carbon ion, which is resonance stabilized. How? By this conjugation. Okay, and this produces this enolate. So this is actually enolate generation by LDA. And look at student temperature. Generally temperature is low for this reaction, proton abstraction, because LDA is significantly highly reactive reagent. Now in the second step, this trimethyl silyl chloride is given because it protects or it abstracts this enolate produced by AN plus DN, means addition of nucleophile and departure of leaving group or nucleofuge, and ultimately it produces oxygen silicon bond or this silicon ether. And please remember, this oxygen silicon bond formation is favored because of two reasons. First of all, this silicon oxygen means if you this is the silicon and this is oxygen, it is not a particular single bond, because this is a sigma bond, it's true. Along with that, silicon has energetically accessible vacant d orbital and oxygen has filled p orbital. So oxygen donates its lone pair to this silicon's d orbital, and that's why the bond between silicon and oxygen is significantly strong. And this is the logic, that's why you see lots of silica or SiO2 is situated in our nature. Okay, so this is a strong silicon oxygen bond formation possible. That is the driving force for this silicon enol-ether formation. Generally we see the nucleophilic attack of enolate happens from carbon side, but this is an exceptional example where the nucleophilic attack happens from the oxygen side, and in this way this silicon enol-ether is produced. Now in the next step is 3,3 sigma-tropic shift happen at 60 degrees centigrade temperature. How? So this is actually student a pericyclic reaction. So this arrow movement is not that much important. So first of all, these 1, 2, these two pi bond and this carbon oxygen sigma bond is involved in this reaction. So what happened? This bond gives here, it comes here, and it comes here. So in this way, see, this bond number 3 is broken, and between 1 and 2, one carbon-carbon single bond is formed. This is okay. So this is the product. And student, the reaction will end up here. No carboxylic acid will be obtained because I didn't mention the anything like hydrolysis, etc. So this is the answer. Now a question is why LDA reactions are carried out very low temperature. First of all, it is a very reactive reagent, and second thing, increasing temperature can result in other proton abstraction too. So in order to get selective proton abstraction, means alpha proton of carbonyl, this low temperature is attained. Now what are the key steps and named reaction associated with this transformation? First is selective proton abstraction by a bulky base like LDA at low temperature to produce the enolate, and trapping of enolate by nucleophilic substitution on silicon center to form this silicon ether. Third is Claisen rearrangement, or you can consider it a pericyclic reaction, or 3,3 sigma-tropic shift to produce the final product. So what is the answer? The answer is option C. Okay, so this is the answer. Now question, why not other? First of all, student, based on your common sense, you can eliminate option A and B. How? First LDA, second TMSCl, just heating, no workup is given. So silicon will be at, because LDA will produce carbon ion, TMSCl will abstract that enolate, the enolate silicon will be there. So option A and B obviously gone. Now let's come to the real explanation. If this question is given in your exam less than 30 seconds, how can you solve? First of all, you need to understand that LDA will generate alpha carbon ion, alpha proton abstraction, and TMS will trap the enolate. This much is true. It's a very common chemistry. Third is heating. Now heating but no workup. From this thing you can understand this trimethylsilyl group will be there in the reaction medium. So option A and B gone. Question, what is options in between option C and D? What will happen? Just look at the reagent. There was no bond between this double bond and alpha of this carbonyl proton. So only one bond formation possible, not two. And if you know Claisen rearrangement, that's very easier. Then that's how easily you can conclude that option C is the right answer. So in conclusion, what we have learned, that LDA is a bulky and stronger base. It abstracts protons selectively. And alpha hydrogen of carbonyl is significantly acidic such that it could be abstracted easily by LDA. And enolate could be protected by silyl enol ether formation. Next, Claisen rearrangement is a kind of acyclic reaction. It's a 3,3' sigma 3,3 sigmastopic shift, and silyl enol ethers are means for silyl enol ether deprotection workup needed, means H plus, OH minus, fluoride, methyl lithium, etc. essential. Without such reagent, the silyl enol ether will remain. Reagent selection is actually dependent for such kind of reaction. Okay, so this is the end of the discussion. I believe this video may be useful. Please, if it is, please help this channel to grow, and if possible, please visit my another channel. And I thank you everyone for watching this video. Stay happy, stay blessed. See you in my next video. Bye bye.